Hi guys, we are going to continue on with what we've been working over the last couple of days. So we're still going to look at quadratic functions. We're going to analyze their changes to standard form. So the first couple of lectures we've dealt with when we have y equals ax squared. So just changing this a term in front of my x squared, whether it stretches it if it's greater than 1, or if it shrinks it if it's less than 1, or if it makes it a smiley face if it's positive, negative face makes it an upside down parabola. And then we've also taken a look at y equals ax squared plus c. So we just want to recognize that c is our y-intercept. So it's where it's going to cross the y-axis. So we're going to keep playing with those and seeing the changes of what's going on. So today, though, in a quadratic function that has standard form y equals ax squared plus bx plus c, we're going to take a look at the changes in the b term, what it does to my graph. So the value of b, so depending on what's in front of the x, affects the position of the axis of symmetry. So right now we haven't had any b terms, and so our axis of symmetry has always just been the y-axis. Now we're going to take a look when we have a b term, how it shifts the graph left or right, depending on the y-axis. So we want to graph the following functions on your graphing calculator and find the axis of symmetry and the vertex. And we want to take a look and see what we can notice about what's going on with the axis of symmetry and the vertex with these changes. So if I'm going to graph y equals 3x squared. So I go y equals, I'm going to clear out all these graphs I already have in here, and 3x squared plus 4. There's no b term, so where should my axis of symmetry be? It should be where it's at the axis. It's going to be the y-axis, so x equals 0. Then we want to take a look and see where our vertex is. So the y-intercept means it's crossing the c at the y-axis at my c term, which is plus 4. So if I graph those out, we can confirm what's going on. I know that my line of symmetry then is what goes right through the parabola, so it's x equals 0. So my axis of symmetry, x equals 0. And looking on my graph, I look at 1, 2, 3, 4. The vertex is at the very highest or lowest point of your parabola. So this point is 0, 4. So my vertex is 0, 4, and it's a minimum. Then we want to take a look like, okay, so that's without without a b term at all. What happens when I have a parent function with a b term and a change in my c as well? So let's go graph that. Y is equal to, I'm going to clear that one out, x squared plus 2x minus 1. And I'm going to put that in my calculator, hit my graph button, and I can see what happens. If you take a look, my line of symmetry, my axis of symmetry has been the y-axis, or x equals 0. But what's happened now, since I have the b term, my axis of symmetry has been shifted over to x equals negative 1. So I've got axis of symmetry, x equals negative 1. And I can find my vertex. My vertex is the lowest point because it's upward facing. So I look for my vertex. My vertex is at negative 1, negative 2. Then let's take a look at this one. So I don't have any change in my c, but I do have a b term. So, and I have a 2 as my a. So it must be narrower than the parent function because it's stretched. And then let's take a look and see what happens to my axis of symmetry with that. So y equals, let's clear that out, I got 2x squared minus 8x. Graph. And it shifted my axis of symmetry to the right. You can see my axis of symmetry goes through the middle here. And my vertex then is also, the x term is on my vertex, so it's at 2. And then we'd have to count down to see how far down it went, and that's at negative 8. It's still showing that my y-intercept is right here. It crosses at 0, 0 because I don't have a c term, so my y-intercept is still 0. So my axis of symmetry is x equals 2. My vertex is 2, negative 8. So that would also be a minimum point. And this would be a minimum because it's also upward facing. So let's do our last one. So we have to take a look at y equals negative x, let me clear that up, negative x squared minus 5x minus 1. And we graph that. And it's negative, so it should be downward facing. That's good. And we can see that my y-intercept, which is the c term, should be negative 1. So if I look at my graph, I can see that the parabola crosses the y-axis at negative 1. And the b has shifted from the y-axis to b. The b has shifted my axis of symmetry over here at negative. So it's not really easy. AOS is equal to x equals negative 2.5. And that's harder to see. 1, 2, it looks like 2.5. And then my vertex is at negative 2.5, because that's what my x value is. But it's hard to see what's going on here. And the reason we want to start looking at how we can do this without graphing it, there's got to be another way I can figure out what my vertex point is. And that's what we're going to work on today. So let's take a look at finding the vertex and the axis of symmetry. So remember your pieces. You've got y equals ax squared plus bx plus c. Your a is your stretch or your shrink. Your b is going to move your axis of symmetry left or right. And your c is your y-intercept. When x is 0, c will be where it crosses the y-intercept. So if we take a look at the three graphs, I've got 2x squared plus 2x. I know my axis of symmetry, which they graphed for me here, is negative 1/2. I've got 2x squared plus 4x. So the only thing I did here was double my b term from 2 to 4. And I have x equals negative 2. Over here, I've gone from 2 and another 2x, and I'm at negative 3/2. Where that does is that leads us into a formula that we get to use for finding our axis of symmetry. So the axis of symmetry changes with each change in the b term. And b is before in front of x. Okay. The equation of the axis of symmetry is x equals negative b over 2a. That means I take the opposite of the sign that b is and divide it by 2 times a. So let's look at the examples up top. So if all I were given was the function and said the equation y equals 2x squared plus 2x and said let's find the axis of symmetry. So I know that the axis of symmetry is x equals the opposite of b over 2a. In this case, a is equal to 2 and b is equal to 2. So I substitute those in. I get the opposite sign of b, which is negative 2, over 2 times 2, which is equal to negative 2 over 4, which is equal to negative 1/2. X is equal, because axis of symmetry is always a line. And that's what we showed in our graph, was x is equal to negative 2, or negative 1/2. So let's take a look at this one. I know a is equal to 2, b is equal to 4, so I can find my axis of symmetry. My axis of symmetry is always an x equals something. We're going to start with the formula, the opposite of b over 2a. We've got the opposite, this is positive, so I get a negative 4 over 2 times 2, substituting the pieces, negative 4 over 4. So x is equal to negative 1. That's my axis of symmetry. And that's what we visually were able to find when we graphed it. In our last one, axis of symmetry, x is always equal to negative b over 2a. Substituting the pieces, I know the opposite of b, so a is equal to 2, b is equal to 6. So the opposite sign, so I need negative 6, 2 over 2, which is equals negative 6 over 4, which reduces down to negative 3/2, or negative 1.5. as my axis of symmetry. Okay, so anytime we have a quadratic equation now, we can find the axis of symmetry. The specific property reads as the graph of y equals ax squared plus bx plus c, where a cannot be 0, because if that's 0, it cancels out and I end up back at a linear equation. Has the line x equals negative b over 2a as its axis of symmetry. The x coordinate of the vertex is the same. So we are solving for the value of x when it is the middle term, or it's like highest or lowest. So it's x, whatever x we find gets put into the vertex, and we automatically know what the vertex is. So let's take a look at finding some of these. Using the function y equals x squared plus 4x plus 3, we want to find the axis of symmetry. So I'm going to real quick go a is equal to 1, identify what a is, b is equal to 4, and c is equal to 3. I know I have an axis of symmetry. My axis of symmetry is always x equals negative b over 2a. Substitute in the pieces I know, so I know my axis of symmetry is x equals the opposite of 4 over 2 times 1, negative 4 over 2, which is equal to negative 2. So x equals negative 2. So I'm going to sketch. That means it can be quick and dirty. So I went 1, 2, there's my negative 2, and I know I have an axis of symmetry. So I'm going to sketch in my axis of symmetry. Then it says, find the coordinates of the vertex of the graph. So I know that my graph, my parabola either goes equidistant away from this axis of symmetry up or down. So I'm going to look, A is positive, so I know I have a smiley face. I need to find the vertex. So I want to know either the highest or lowest point on this line that's going to make my parabola. So I know that I have already found x. The vertex is an xy point. So if I want to go find the vertex, I need to just find what the y value is. I do that by substitute x into the equation. So once I find x, I'm going to substitute it into the equation to find y. Okay, so I know my equation is y equals x squared plus 4x plus 3. So I found x already, so equals negative 2, when I substitute it, put parentheses around it, squared plus 4 times negative 2 plus 3. Equals negative times a negative is a positive 4. 4 times a negative, that's negative 6 plus 3. I got negative 2 times 4, that's negative 8, sorry. 4 times negative 2 is 8. Negative 8. And a positive 7 gives me negative 1. So y is equal to negative 1. I finish my vertex as a point. I should have the vertex at x, which is negative 2, y, negative 1. So I go to negative 2. 1, 2, there's negative 2 right there, and negative 1, and I have my parabola. Y equals x squared plus 4x plus 3, x and a y. Okay, so that's what we're going to work on most of the rest of it, and we're going to take a look at some of the application problems as well. So it says find the axis of symmetry and the vertex. Step 1, axis of symmetry. So axis of symmetry is x equals negative b over 2a. I go up here, a is equal to 3, and b, there's no b term. If there's no b term, I must have multiplied by 0 to get rid of the x. So I substitute in the pieces I know. I get negative 0 over 2 times 3. 0 divided by anything is equal to 0. So x is equal to 0. Should always be in an x equal form. Should be an equation. It's an equation of a line. And then it says to find the vertex. I know I substitute in y. Substitute in x to find y. Since I know what x is, I'm going to substitute it into the equation. So y is going to equal 3x squared plus 3. 3 times 0 squared plus 3. 0 times 0 is 0 times 3 is 0. So y is equal to 3. I'm not done until I have a point. My vertex is the point 0, 3. Alright, one more before you guys try. We have the function f of x is equal to negative x squared. So a is equal to negative 1, b is equal to 8. It wants me to find my axis of symmetry. So I know it's x is equal to negative b over 2a. So the opposite sign is negative 8 over 2 times negative 1. I get negative 8 over negative 2. Negative divided by a negative is a positive 4. The answer is always x equals 4. This should be my final answer. Should be in a form of an equation. Then I want to find my vertex. My vertex means I need to substitute in my piece. So I'm going to take negative x squared plus 8x minus 5 and substitute in for x. 4 squared plus 8 times 4 minus 5. Now remember, your negative is not touching, is not in parentheses here. So the negative is going to come down with it. So 4 squared is 16, and that's going to equal negative 16. 8 times 4 is a positive 32 minus 5. So I know that y, when I simplify, is equal to 11. I'm not done until I give me a vertex point of xy, which is 411. Okay, pause the video, try those next couple, come back and check your answers. Okay, you should get your axis of symmetry at x equals negative 6 and your vertex at negative 6, negative 45. Your axis of symmetry at x equals 1/2 and your vertex at 1/2, 3/4. If you didn't get those, make sure you go back and try and rework them and then come in with questions tomorrow. Alright, let's quickly jot down what the steps were that we just did. So instead of using a table, we can start to graph quadratic functions a lot easier without the table. We need to find the equation of axis of symmetry. We do that with x equals negative b over 2a. We need to then find the vertex by substitute the x from your axis of symmetry into your equation. The last thing we need to find is the y-intercept. It's a point. We already know how to do this. We know the y-intercept is our constant or our c value. It's the point where the equation crosses y-axis. And then we're going to plot other points using symmetry. So we'll see what that means. It's pretty easy. So let's take a look at the following. Graph the following functions. We want to use our 4 steps that we have here. So we are first going to identify, hey, I have a equals negative 3. A is negative, so it should be downward facing. B is equal to 6, and C is equal to 5. Step 1, find your axis of symmetry. We know our axis of symmetry is x equals negative b over 2a. Substitute in my points. Negative 6 over 2 times negative 3 equals negative 6 over negative 6. So that's equal to 1. So x is equal to 1. So I now have my axis of symmetry at x equals 1. So I'm going to go over here to x equals 1 and drop in my axis of symmetry. So I know my parabola has to be around that axis. Step 2 says find the vertex. So we need to find the vertex. Well, I know the x part of it already. I just need to go find the y. So my vertex is when I substitute in the pieces. So for x, I'm going to put in 1. So I get y equals negative 3 times 1 squared plus 6 times 1 plus 5. 1 squared is 1, negative 3 plus 6, that's 3 plus another 5, that's y equals 8. Your vertex is always a point, 1, 8. That's how it should be answered. So I go over here and I go 1, 2, 8, which is way up here at the top of my graph. Next step says find the y-intercept. So I'm going to document the next step by finding the y-intercept. The y-intercept is 0, comma, c. Because remember, in our equation, the c term is where it crosses the y-axis. So the y-intercept is 0, comma, c, which is 5. So I'm going to go to 0, 1, 2, 3, 4, 5. That's where it crosses the y-axis. It says plot the other points. So I know if I have one point that is 1 unit away from the axis of symmetry to the left, I need 1 point away to the right. And I have my upward facing graph. Y equals negative 3x squared plus 6x plus 5. So let's try another. So function of x, f of x is equal to negative x. So I know it's downward facing again. So I know a is equal to negative 1, b is equal to negative 4, and c equals negative 3. So I know it's going to cross my y-axis at negative 3. So step 1, axis of symmetry. X is equal to negative b over 2a, which equals the opposite of b. Now it's negative, so it becomes positive, over 2 times negative a, which is negative 1. So I get 4 over negative 2, which is equal to negative 2, so x is equal to negative 2. I go and graph my line of symmetry at x equals negative 2. Second step is to find the vertex. So what is the minimum or maximum point on that axis of symmetry where my parabola is going to be? The vertex is finding the y. Y equals negative, I'm going to substitute in negative 2 squared, minus 4 times negative 2 minus 3. Negative 2 times negative 2 is a positive 4, but the negative comes with it, so I get negative 4. Negative 4 times the negative 2, that's a positive 8, and negative 3. So that leads me to y equals 1. The vertex is always a point, negative 2, comma 1. So I go to negative 2 and I go up to 1. I know I have a negative a, so it needs to be a sad downward facing. So my last step, step 3, is to find the intercept. The intercept is easy. Y-intercept is where you have 0, comma, c. In this case, 0, comma, negative 3. So that's where the parabola crosses over the y-axis. 1, 2, 3. That's 0, negative 3. Last step. 1, 2 away from the axis of symmetry. So I'm going to go 2 to the left. I now have my shape. Make sure it's rounded. No V's of my parabola. You're going to pause the video, try the next 2. Okay, the last thing I want to take a look at is application problems. These can get kind of fun and then get a little tricky too. So I'm working in professional fireworks. The aerial fireworks carry what are called stars upward, ignite them, and then project them into the air. So it goes up, then it gets ignited and goes up even further. Suppose a particular star is projected from an aerial firework at a starting height of 520. So I know if I take a look at my height, I'm starting at 520. So that's going to be my axis of symmetry. And then it says I shoot it up at an initial velocity of 72 feet per squared. So I know it's going to shoot up, but gravity kicks in at some point and eventually that firework comes back down and hopefully doesn't land on anybody. So what we need to do is it gives us the function, so someone already wrote the function for us to tell us the star's height after t seconds. So we want to know how high. Well, that's going to be my vertex. So I want to find the vertex to figure out how high that firework went. Well, the vertex lives on the axis of symmetry. So I need to find my axis of symmetry in order to find out what the vertex is. And for height, I want specifically the y value, because this is my y-axis, this is my x, and this is height. So I need the y value to tell me how high, and the x value is time, and how much time it took me to get to my maximum height. So let's figure it out. How long will it take? How long will it take? So that's the number of seconds. So these are seconds. Will it take, and these are feet, to reach its maximum? So I want to know how high up it goes. So I need to find the axis of symmetry, because that's where it lives on the x-axis. So I know my axis of symmetry is x is equal to negative b over 2a. In this case, they gave me the function. So I know a is equal to negative 16, b is equal to 72, and c is equal to 520. So if I substitute in my pieces, I know that it is equal to negative 72 over 2 times negative 16. I put that into my calculator, and I get 2.25, which means it takes 2.25 seconds to get max height. How far above the ground it will be. So my x value is time. How far above the ground will it be at that maximum height means I need to find my y. If I already know what my x is, then I can substitute it in to find my y. So I'm going to take my original equation, h equals negative 16t squared plus 72t plus 520. So in this case, x is really time. So I'm going to change that to t. And I know my height is my y, so that's my h. So I'm going to find negative 16 times 2.25 squared plus 72 times 2.25 plus 520. This should be easy because we have a tool that does it for us. I should be able to put that exactly into my calculator and come out peachy. So negative 16 times 2.25 squared plus 72 times 2.25 plus 520. So exactly as you see it, put it in your calculator and you get 601. So equals 601. Max height of 601 feet. Okay, let's take a look at dunking a basketball. So same concept here. We know that we have some type of function. It says you're trying to dunk a basketball and you need to jump 2.5 feet in the air to do it. So I need to be able to jump 2.5 feet in order to dunk the ball. The height that your feet are above the ground is given by the function negative 16. What is the maximum height your feet will be above the ground? So this tells me how high I can go, and I want to see, hey, is it going to get me at least 2.5 feet up using this function so that I can dunk the ball? So I'm still thinking that I'm going to sketch height and time. And in this case, it's not asking me how long. It's just asking me, hey, as a person, am I going to be able to jump to make this basketball hoop? And I need to be able to go 2.5 feet high. So let's figure out if we can do it. I'm looking for how high. So I'm looking for the y, which is equal to h. But in order to figure out how high, that height lives on the axis of symmetry. So I need to find the axis of symmetry so that I can figure out what x is, so that I can figure out what y is. So I'm going to start with my axis of symmetry, which we know is negative b over 2a equals, let's see, a is equal to negative 16, b is equal to 12. So I'm just pulling those right out of the function they gave me. So I know negative 12 over 2 times negative 16 is equal to negative 12 over negative 32, which is equal to 0.375. So it didn't ask us, but that tells me, hey, in 0.375 seconds, I'll be able to jump however high this is going to get me. So let's figure out how high I'm going to get. So I need my vertex. The height hangs out on the y hangs out inside my vertex. The vertex means take your x and substitute it in. So negative 16t squared plus 12t. My x is my time, which is t. So equals negative 16 times 0.375 plus, what is that, 12? 12 times, I probably should put a 0, 375 equals. Put it exactly like you see it in your calculator, you're going to get 1.8. That's in feet. Was I able to jump 2.5 feet? Nope. Can't dunk. Max height 1.8 feet. Okay, we're going to circle example 3. We're going to come back to profit and loss later. You can take a look at that later. I want you to try the next couple, answer those, come back, check your answers. Okay, you should find that it takes you 1.5 seconds to reach your maximum height, and that maximum height is 40 feet. Pause the video, make sure you know how to do this, jot down any questions you have, and I'll see you in class.